What we're going to do now is export our floor into our CAD drawing so that we can create our detailed layout drawing and our fabrication drawings as well. Before we export a floor, obviously the key thing is this status column. We need to be able to see that everything has passed all the checks that are necessary to make sure everything is working properly, and we're happy with that. What you can do when you export a floor is you can tell MultiSTEEL in AutoCAD what size plates you want to use for top plates and for base plates. I'm happy with the base plates that I've got chosen here because my bearing pressures are very reasonable. But I want to just have a quick think about my cap plates. These beams, these inner beams, have a 127 flange, and my standard cap plate has a 100 wide flange. So really I want to use a slightly wider cap plate. So what I'm going to do is change my inner cap plate, which we do in this Detailer tab. Click on Top Plates, and here is the dimensions for my top plates. Now I have a standard top plate or cap plate in my library, which is a 130 250 by 15. So it's a more substantial cap plate, and I feel better using that than using that narrow one. The 100 wide cap plate is fine for the outer beams, but we need a slightly wider one for the inners. Whilst I'm on this page, this is the gap. If you remember on the first video, we set a tolerance gap of 6 millimeters over our cap plate, and this gap basically means reduce the length of each beam by 3 mil. So we get a 6 mil total gap at each cap plate position. Okay, to export our floor, we go to the Export tab. We want to export our connections. I don't want to show my column base loads. That is an option. You can show them on the CAD drawing. If you have a job where details are going to have to go to an engineer, you can show him the column loads actually on the drawing. They're actually on a separate layer, so you can switch them on and off, but we don't really need them in this case. My default base plates are okay. I want to change my inner top plate to a 250 130 15. So that matches our design within MezzQUOTE. The outer top plates are okay. The cleats, I'm going to use a 170 because I'm using a 170 joist, and the holes, they're the holes for the tie bars, a 170, and I'll use an M12 tie bar. There's also M10s in that list as well. Okay, over here we've got a couple of options. I don't want to include the decking profile because I've already got that drawn within my CAD drawing. Set top of steel to Z equals 0 in AutoCAD. That effectively sets the floor down to the 0 level in AutoCAD, which is the level that I've drawn my building outline. So that makes editing easier. You don't really want the floor, up in the air by 3 meters and your building outline down at 0. So it actually drops the whole floor down by 3.2 meters in this case. We're now going to browse to where we want to save our file. So I'm going to put it in my folder, which is here. So I'm just going to give it a name. So I'll call it EG1 SDF file. Doesn't matter what you call it, obviously. What it's doing there is it's exporting all that data into a transfer file. It's called an SDF file. It's a steel detailing neutral file. It's a standard industry format. We've actually modified it to include all of our connection information. So I'm happy now that I've created my transfer file. What we can do next is go back into AutoCAD, back into MultiSTEEL Mezanine, which is running in AutoCAD, and import our floor into our layout drawing. So that's what we'll do in the next video.